Welcome to another Great Cow Basic tutorial. This is part 12 for the PIC18FxxQ41 family of chips. We're well into the tutorials now. We're looking at EEProm today, and I'll explain what that is. And what we're going to be doing is showing the values of EEProm on a serial terminal as an example, and you're also going to be showing them on a programmer. So what am I using? I'm using the microchip low pin count demo board, and hopefully only a few more days to go, but I still want to do something with the Curiosity Nano board when it arrives. Let's have a look at the lab. There's the actual board I'm using. It's attached up. I've taken all the other connections off we had on previous tutorials. We just want one today, two connections today. Let's get started. This is the layout of the board that you've just been looking at. You can make your own up to copy the design. Relatively simple. This is by Chris Roper, a colleague and a good friend of mine from South Africa. So let's have a look at what we're talking about here. EEProm. What is EEProm? It's electronically erasable programmable read-only memory. It's a lot easier to say EEProm, and it's a type of memory, a non-volatile memory that's actually within the microcontrollers. It's used extensively throughout the industry, and you can store relatively small amount of data. You can erase single bytes and reprogram that byte, and I think this particular chip has got 256K, others have 1024, some have 2048 bytes. They're very you look at them in a particular chip, okay, and that value is quite small compared to the overall memory, but it is non-volatile, therefore it survives a power on and reset. Now, what we're going to do is get into the lab as soon as possible, but all I've got connected up today is a ground and the TX. We've seen those connected up before, and as I've said previously, I always use the same color cables. I'm quite laborious about that, and I've just connected up the green to the RC6, and what we're going to do is put the data, we're going to write data out to the EEProm and then read it and put it on a serial terminal, hence I need to connect up that yellow cable to my serial connector. So what we're going to do is we're going to go through and we're going to, let me just bring my pen up here. I'm going to write some stuff out, EP write, to the EEProm in the chip, and then I'm going to read it back out, and I'm going to put it on the terminal. That's one thing we're going to do. It's quite simple. This is showing random numbers, and then I'm going to show you another way you can create a table in memory, and then a set of sequences, and then I'm going to read those back in via a programmer so that we can see them change. Okay, we can see them being updated, and the file that we're going to create has these data in. So there's two ways I'm going to show you today, and there are many other ways. Okay, but they all revolve around the commands are on the screen now in terms of EP write, EP read, these two commands, or using a table to make that happen. And they're very, very simple, and there's nothing complex around using EEProm with Great Cow Basic. So what we're going to do is we're going to use PPS. I've spoken about PPS to set the serial port up. We're going to write some values out to EEProm and read them back, and we're going to see the results on the terminal. Then secondly, as I said, we're going to write some values out in table and read those back via PIC18FxxQ41, the programming software. So let's go into the software. What have we got here? Do a code walk, and then we'll see it work. Let me bring that across from that screen here to here. There we go. So we've got our normal chip setup, hash chip, and explicit. If I zoom in on that a bit closer for us, there we go. Those are required. You need to specify your chip and option explicit. Doesn't matter. I've chosen the 16Q41. It could be any of the Q41s. We've seen previously how we set up the PPS. This is the PPS segment. You go into PPS tool, select the output port for the TX for the transmit one, and it will create the code fully automatically for you, and you just paste it into here. We've seen before that we've got it documented. And this is a documentation section, and you can do it any way you like. This is the way I will give it back to you with demonstrations. Okay, I'm putting the TX on C6. Let me explain that to you. So this is port C, this is pin 6, and I've got the transmit connected to there. The others are documented because there are things connected to port A in terms of a switch and the ADC. We've seen before how we set up the defines and the directions on the digital outputs, and we've seen before how we set up the USR in terms of its baud rate. Because we're looking here for the EP write stuff. So this is a load of formatting that puts it out on the screen. So I think what we'll do is we'll actually program it, okay, and then we'll actually program this, and then we'll see what happens in terms of the software. Okay, let me just bring up my desktop. There's my desktop there. That's not a really good one, is it? Really? There we go. Programming. I've lost it. Zoom SynWrite. That's what I want. There we go. Great. So I'm going to program this in using the program button here. And as it programs it, I'm going to bring the terminal onto the front. And I've got the terminal hooked up, and it's just going to reboot. It's just programming as I speak, and it brings up a series of values on the screen, which is quite nice. Those values relate to the memory, the extent of the memory that we were looking at. So the memory itself has been populated by a series of values, and you can see those on the screen in terms of 6B through to here, and this is the RAM that's available in this computer here, in this microcontroller. And so this is 0001, and this is just a little hexadecimal table to say that if you wanted to know what was in 30, it's A1. Hard to see on your screens, I would imagine, but let me just see if I can zoom in for you. There we go. Look at that. Remarkable. So at 330 is A1. Let's walk the code to see how we made that happen, because that's what we need. That's what we're here for. Looking in detail at the code. The code itself has a series set of 8 H serial print commands, which is just the layout. But essentially, all I'm doing here is doing what's called an EP write. I've got a for next loop with what's called the EEProm address, and the EEProm address starts at 0 and goes to the end of the EEProm memory. Let's have a look at that for next statement. Here it is here. Here it is here. For EEProm equals 0 to chip EEProm minus 1. And chip EEProm is the value of the amount of EEProm available on this specific chip. So EEProm is a variable, and we're going to pass EP write that variable, and we're going to pass it some out data. And the out data happens to be a random number. And then I read it back in, same address, from the same address in EEProm, and I put it into something called out data, in data, and then I put it on the screen. So I've got a random number, I write it out, and then I read that number back in and then put it on the screen. And that's what we saw in terms of the terminal. That's exactly what we saw in the terminal. So if we change the code in here, and I'm actually going to change the out data to just prove things, is I'm going to say to it, write out the out data is going to be 255 less the current EEProm address. So it will go from 255 down to 0. If I program that up now, we'll see that these numbers are sequential, but in reverse order. Zoom in on terminal, it programs it, and here we go. Look at that, perfect. As we can see, 255 in the terminal, 254, etc., etc. So the learning in this is very simple. The software called Great Cat Basic has two commands: EP write with a location and a value for bytes, and EP read, the location and the variable you want to put the data in, and then you can do what you like with it. You can manipulate it as you see. Two major commands: EP write and EP read. That is one method. we have a second method. The second method is to write a table out. I've not changed any of the code above, and essentially we create a table of values, and this is the actual, let me zoom in on that for you. We create a table. I've given it the name table data source. I'm saying store that in data, and that means store data means put it in EEProm, and I put some values of 1 to 6 in that table. I've also written out using EEPwrite to location number 7 a value of 22. Random number, I could put it as 23 as far as I'm concerned. So what I'm saying here is that put 1 through to 6 in memory in EEProm, and then write another value out behind it called 23. Let's just create a hexadecimal file, and then what I'm going to do is then bring that file up here into PIC18 software. Let me bring that up. There we go. What you see on my screen is always ahead of what I can see here. If I open that file, I import it into here, we will see, I will just check that button there, look, re-import it. We can see in the middle of the screen it says the word source, and that is the file that I've just compiled, trust me. And there's a program in here in memory. It's not that long, it finishes here, but that's all the program memory. But look down here, I've got some values. I've got 6 values that I wrote out, 1, 2, 3, 4, 5, and 6. So that data from my Great Car Basic was automatically written in my hex file. Watch this. I'm going to write that out to the chip, and the last byte will be written out by our active program. Our active program will write the value hex 23 to location 7. Let's prove that by reading it. And here it is. So, 2 methods I've just used. I used the method of writing out the table, creating a table to store the data in EEProm automatically. And these are, I've got them as horizontal lists. You can use commas and whatever you like. It's up to you how you do it. And then I've written a single value out just to prove that the code was real. So if I write the number 55 in here, I select hex and flash, it will hex and flash it for me. And then if I come into my PIC18 software, which you can see on the screen now, I read that in, we will see the value of 23 change to 55. Using EEProm with Great Car Basic is relatively simple. Learn the syntax and the magic happens. That's it. So tomorrow we're going to be looking at I2C GLC display, looking at how it works. I'll actually put up a couple of demos just to show you how it works. We won't go into too much depth, just for part to show you how I2C works in terms of the command set, and then we'll do another GLCD after that. So really I wanted to show you this today, which is EEPwrite, EEPread, and how you use a table to create EEProm data. And with that, we'll call that a wrap. Thank you.